So now we're going to run a disconnect test, and this is a good example. We're actually in the meter accuracy setup screen, but to show that when you want to go to any particular screen, you can always exit out by using this back arrow here in the bottom right corner, and that'll take you to the next higher screen. So you hit that, and then you have a disconnect test screen, but I can show you how to go back to the main screen. This is the basic screen it comes up with. This is the main screen, and you can scroll in anywhere from the screen. So in order to start a meter, this automatically senses when the meter is correctly aligned, will close the jaw and turn the light on. So I will press it in here. You can hear the motor inserting the meter. The light is on, now it's properly inserted. So now I will select a disconnect test. I do that by selecting the test function here. And then you have various tests, and here you have disconnect test. So you press disconnect test, and the meter we've selected is a form 2S. So it asks you for a form 2. It automatically will select 240 volts. You can put current on it. There are a few different functions here, but it's pretty much limited to a disconnect test screen. And in order to do this, the 2990 does not actually do the disconnect test. It facilitates a disconnect test run from a laptop. So the laptop comes with this very nice Landis & Gyr optical pickup that we will put on the optical port. And I am now in the Landis & Gyr software program, and I will select the meter tools. And I have a drop-down menu here that will select the disconnect test. So what I have to do is power up the meter so it now can communicate. There's a power on switch. This basically puts the power on the meter. When it comes up, it'll show that it's in disconnect test, green, and that jaw 2 and jaw 4, where the bottom jaws are now hot, which means the disconnect is closed and the customer is receiving power. So now to do a disconnect test, what happens is the meter opens up the connection to the 2 jaws, and these lights will go out and the customer will be removed from power. It's in disconnect test mode with power on the meter and to the low jaws. And now we're going to use this software to perform the disconnect. Toggle service disconnect. It gives you some communication protocols. Now it's connecting to the meter is responding, and it'll come up and it'll show the disconnect circuitry that's inside the meter, and we can actually put load on, disconnect with load. And if we refresh, we'll see that the meter now has load on it, and we can open the disconnect. It takes a minute to respond. You'll see that no back voltage, no current. The jaws have gone out, so now the meter is open and the customer no longer has power. So they better pay their bill. So in order to do a test, we can turn the back voltage on, and then we can hit refresh, and it will show that we now have a voltage on the back circuit, and it will not try to close on this because it has a load side voltage. So we can turn the voltage off again, and now it should close on the circuit that has no voltage. I'll hit refresh and display that now there is no back voltage. See, the meters have a circuitry in there in case the customer has connected a generator or connected an extension cord over to their neighbor and brought power in. They don't want the meter closing on. It's a safety factor. They don't want the meter closing on live power and may cause an explosion at the socket. So it checks, it has circuitry in there that checks the back voltage condition, and customers want to check that. So it's a good thing. It looks there, now it sees there's no voltage on there. It's safe to close, and I'll be able to close the disconnect switch. The lights come on, jaw 4 and jaw 2 are now hot, and we will say that this meter's disconnect circuitry now works. And you can see that power has now been delivered back to the load side.